Okay, today we're going to be talking about some key features of functions that we're given. So we're going to kind of go through these functions and dissect them to get as much information as we can out of them. Functions are going to be really important this year throughout the entire course. So most of this you've already learned, but we're going to refresh and kind of go a little bit deeper if we can. Okay, so we've got the function f of x on the right. We're going to answer the questions and work through it piece by piece. So first thing we're going to do is we're going to state the y-intercept of the function. Y-intercept, again, is where it crosses through that y-axis. And in this case, the y-intercept is the coordinate point 0, 2. The x-intercepts of the function. What is the alternative name that we give the x-intercepts? Okay, so here are our x-intercepts, here and here. So we have 4, 0. And negative 6, 0. We also call these roots, the roots of the function, or the zeros of the function. So over the interval from negative 1 to 2 on the x-axis, I want to know, is my function increasing or decreasing? And how can I tell? So just like when we read a book, we read left to right. When we're reading functions, we read left to right. So if I'm looking at negative 1 to 2 on this interval right here, is my function increasing or decreasing? That's what I'm looking to understand. Again, we're reading left to right. So if I were to jump on this function and write it along the interval, am I increasing in my height or am I decreasing? So since we had to go up, I would say that my function is increasing. So we read functions from left to right. Okay, we read functions from left to right, and if it's going up, it's increasing. If it's going down or lower on the y-axis, it is decreasing. Okay. We're going to give the interval over which f of x is greater than 0. What is a quick way of seeing this visually? Okay, so I want to know, where is my function greater than 0? F of x, again, is another way. It's function notation for y. So when is y greater than 0 on what interval? So if I'm looking at this graph, where does that occur? Well, here's y equals 0, which is my x-axis. When is it greater than it? Everywhere up here. So where does my function exist? What is the interval for which it's in that green space, right? So basically we're looking at for where the function is above the y-axis. Or is my function above the y-axis? And that's on the interval, and I apologize for my view here. It's on the interval from negative 6 to 4. And that's where my function exists above the x-axis. State all of the coordinates of the relative maximums and the relative minimums. Label each of them. Okay, relative max, relative min. Looks like I have, state the x coordinates, relative max, relative min. There's my mins and my maxes, right? So looks like I have a value here of my relatives are going to be those that are not the highest or not the lowest. Okay, so the highest one, I'm going to take that out. The lowest one, I'm going to take that out. Okay, these are your relative maximums and minimums. This is the point negative 4, 6 for my relative max. Okay, and this is the point negative 1, 1 for my relative min. Now the ones that were the highest or the lowest, those are your absolute maximum and your absolute minimum. Okay, so your absolute maximum is this value here, which is 2 8, and your absolute minimum is going to be the value or the coordinate point 5, -2. Please make sure you write that under E and F. Okay, the next thing we want to talk about is what the domain and the range of this function is. Domain and range is going to be very important not only for this course but in pre-calculus, so we want to make sure that we're clear on domain and range. Domain and range is something that you spent quite a bit of time in 9th grade going over as well. So you should know that the domain is the x values of my function, right? So what values of x are being used for this particular function? Well, my function is from here to here, right? The x values that are being used are everything in between. For range, we're looking at the y value. So my maximum height is here on my function, and my minimum height is here. So it's everything in between, okay? So my domain is the interval -8, which is right here, right, to 6. Those are all of the x values. If I were to plot all of these points, we would use those integer values, right? My range is from -4 to 8. There's my domain, and there's my range. So these are the types of the pieces of information that you need to be very comfortable with pulling out of these functions. The last question, H at the bottom, says, if a second function, g of x, is defined by the formula g of x equals 1/2 f of x plus 2, then what is the y-intercept of g? Now, we said the y-intercept of the function was the point 0, 2, right? So basically what this is saying is it's saying, okay, I'm going to take the x and I'm going to add 2 to it. Okay? I'm going to move it to the left. Oops, that's an F. It's supposed to be an L. We're going to move it to the left 2 places. And we're going to multiply the y by 1/2. Okay? So the x moves 2 places to the left. So the x value here, 2 places to the left. The y value gets multiplied by 1/2 or divided by 2. So this becomes what your y-intercept was. We want to take and do that for each point. So if I want to know what the y-intercept of this function would be, I have to go up, take a look at this graph, 1/2 f of x plus 2. So I'm taking this value and shifting it 2 places to the left, and then cutting it in half. So dropping the height in half. Okay? So if this height was 2, now it's 1. If this height is 1, now it's 1/2. If this height, do you understand what I'm saying? 1, 2, 3, 4, 5. This is going to be 1, 2.5. So it's going to drop everything down by 1/2. Or shrink it, I should say. Okay? Okay. Let's take a look at that next page. All right, so we've got the function g of x equals 2 times the absolute value of x minus 1, minus 8, defined over the domain from -4 to 7, inclusive. Now, if it's giving you a specific domain, that means you are not graphing outside of that domain. You're not extending past with arrows. It is a very exact domain. So be cautious when you do this. When we do this, it's okay to make those tables of values. We want to do that. You have a calculator that can help you do that. You are more than welcome to use it. Okay. So if I wanted to graph this, so that I could get a table of values. I've got 2 times the absolute value of x minus 1 minus 8. And again, this is not what I am graphing because I am on a very restricted domain. I just want the table here. Okay, this is how you would get it. Control T brings up that table so that you can pull these points out so that we can plot this. Okay, so my table, I've got -4, 2, -2, -2, 0, -6, 1, -8, 2, -6, 4, -2, 6, 2, 7, 4. So that's on my restricted domain. Notice I started at 4 and I ended at 7. Restricted domain. -4, -2. I'm sorry, -4, +2, wrong direction. -2, -2, 0, -6. My y-intercept, 1, -8. 2, -6. It's an absolute value function. It is symmetric. 4, -2. It's symmetric to the vertex. And 7, 4. Okay, so here's my absolute value. State the domain over which this interval is decreasing. So reading left to right, where am I going down? So here is where my function is decreasing. So decreasing from -4 to 1. Right? The x values, you're looking at the x values. Where on the x-axis is it decreasing? And where is it increasing? Am I asking where it's increasing? No, I just want where it's decreasing. Okay, so that's where it's decreasing. State the zeros of the function on this interval. So where is it crossing that x-axis? We are crossing the x-axis at -3, 0. As well as 1, 2, 3, 4, 5, 0, or -3 and 5. And the interval for which the function is less than or equal to 0. So less than or equal to 0 is going to mean equal to this or below it. So all of this is less than or equal to 0. Again, the interval means we're starting at the x value. So from here to here, this entire portion, I am less than or equal to 0. We're going to put it in square brackets because it's equal to, so we're including it. So from -3 to 5. Okay, we want to evaluate g of 0 by using the algebraic definition of the function. What point does this correspond to on the graph? And then we want to determine any relative maximums or minimums of the graph. If so, which and what are their coordinates? So we're going to skip to F for just a second. We'll go back to E. If I'm looking at this graph, I know that I have a minimum, and we're going to state the coordinates to be 1, 8, -8. Okay, that's my minimum. So now let's go back to this other question. I guess I'm losing my ink here. All right, so if I want to evaluate g of 0, and I want to do this algebraically, we have evaluated, we've been doing this for quite some time. We know that this is simply substitution. G of 0 is going to be -6. What point does this correspond to on the graph? Well, this is g of x, right? So x is 0. G of x is the same thing as y, so y is -6. 0, -6 is my y-intercept. So when x is 0, we get our y-intercept. we're almost done. I know this is a longer video tonight. Okay, so we also have to be able to look at functions in a tabular form as well, so that you need to be comfortable with this too. This function is a continuous function, which means there's no holes in it, there's no jumps, it's fluid in nature. On the interval from -6 to 13, that's my domain, with selected values shown below. Function has exactly 2 zeros, which means that's where it crosses the x-axis, and has exactly 2 turning points, which means it's going to have a maximum and a minimum. One at 3 and -4, and one at 9, 3. This is a polynomial function. State the interval for which f of x is less than 0. So f of x, again, same thing as y. Where is it less than 0? Or in our case, negative. We are negative on the interval from 0 to 5, right? Right here. State the interval for over which f of x is increasing. So where are my values of y getting larger if I'm looking from left to right? Okay, well, my values are getting larger from here, -4 to 1, right? It's getting bigger, to 0 to 3. That's where it stops getting larger. So on that interval from 3 to 9. Okay, so again, if you have questions, please come prepared to class tomorrow. We will answer them at the beginning of class. Make sure that you, in Google Forms, if you do have a question, it is being put into that form so that I can aggregate all of those together for class. All right, we'll see you.